So what you can see here is I've downloaded this node exporter. I went to temp direct and I just executed this one command, curl -lo. This slash indicate that my command I want to continue in the next line. I don't want to continue in the same line. I want to type in the next. Like for example, if I use up arrow key, you will not see that slash. So actually command was this: when you break the command into two lines, you put slash. So that was the purpose. So I downloaded this from GitHub Prometheus node exporter release 1.3.1, which is latest, and this is the compressed file tar.gz node exporter 1.3.1 Linux AMD 64. So naturally what I'll do is I'll extract the file tar -xvzf and node exporter. If you see, there is only one binary file here, and that is node exporter. So we, as usual, will copy this file node exporter / node exporter, this binary, into user bin directory. So we copy it, and we may also need to change the permission if it is not there. Chmod a+x means for all users I want to give execute permissions to this node exporter file which I copied. So change the execute permission. Now what I will do is I'll create the user also to be owned, and I'll create a service file as here. User add no home directory, no shell, the shell is false, and create a user with the name node exporter. Now that binary should be owned by this user, chown node exporter username group name, the file which I copied, that is user bin node exporter. So our directory, our file is set, permissions are set properly. So we need to create a node exporter dot service file, the systemd unit file, the way we created for Prometheus and Alertmanager. So this will help us to manage this node exporter with systemd script, systemctl. I am working on this file, the unit file, systemd unit file. And if you see now the semantic and the concept, I'm sure by 3 examples you know that first section is unit, the name of the unit, and the relationship with the existing unit. So we require network target, which is mandatory. So after this unit should start after the network. Then service. So service name is node exporter, username node exporter group, and the type and the execution, how this script should be started. This is the binary file which we copied. So we can save it now. So this will start, it will reload the daemon and enable this node exporter and start it right now. This command enable --now serve two purpose. Like I could have done it in two commands, systemctl start node exporter and systemctl enable node exporter. This in one command, if you want to do that, you can use it enable --now. And I can check this status now because I want to verify. Naturally I want to verify, so I'll use status node exporter. My node exporter is running. So this is a kind of server which is available on address 9100. So this is exposing, it is a service listening on port number 9100. So I need to open this port, firewall -cmd --permanent add port equal to 9100/TCP, and I need to reload it. So my node exporter is configured successfully. It will be collecting a lot of data from my operating system and will make it available to be scrapped. So who will scrap it? We have Prometheus which can scrap it. So we will configure Prometheus to scrap this target now, because we have created a target which will be scrapped, and that will make my operating system data available to be scrapped. So I will use this file now and I will create a job, and this is the how we specify the targets. So scrap configuration, this is Prometheus, but here I will open my own job. I'll specify my own job for node exporter. Now this is wrong. If you copy blindly like this will not work. Prometheus even will not start. Remember that it is a YML format, and this element, when we start with hyphen, that means this is list element, and this list element completes here. Next element should be in the same format with same indentation. Therefore, what I must do is hyphen should be below hyphen, alignment should be exactly matching with this. If it doesn't match, it will fail. Prometheus will not start. So now you can easily see that. In fact, you can keep a blank line to confirm that okay, this is one job and this is another job. So we have two jobs here. It means two targets. Two Prometheus targets are configured. One is for Prometheus itself, and second is for node exporter, which is running right now, and which is available at port number 9100, and which I opened. So I can save this. Before I verify, I would like to show you the Prometheus which is available at port number 9090. This is my Prometheus, and if I check my targets, I will see one target so far, and that target is Prometheus itself, which was given in the job name, first job. And if I want to monitor this node exporter also, and I want to add that target here, I just need to, I have already done that, so I just need to restart my Prometheus. So systemctl restart Prometheus. Check the status. Perfect. And now if I refresh my page, I will get the second target also available. And here we go. So this is my node exporter. And these are the metrics available for node exporter. So node exporter is making this data available. Now this is the behind the curtain story team. Node exporter is binary, which is pulling the data from my Linux machine, and which is creating this data available at port number 9100. So Prometheus is going there and is pulling that data, and this is one at this point in time. This is the query. So GOGC duration seconds, and this is the label which I discussed yesterday, and this is the value. So here you can refer to these also. Help go GC duration second, a summary of pause duration of garbage collection cycles. Then similarly, you can check each and everything. This is number of garbage, sorry, this go routines that currently exits. So every metric have a name to it, like total CPU seconds total. So a lot of data on CPU is available. This is the node discard. So these are, you can say, these are metrics collected. And how can these be relevant to me? I will write the query here and I'll plot the graph. Let me show you some queries. Like I want to see the free memory available. So node memory free bytes, that is exported by node exporter. This is showing last 1 hour data, but my node exporter is available for last 2 minutes only. So I'll type last 5 minutes, 5M, 5 minute. And that will show me the last 5 minutes of data since node exporter had started collecting this data. And this is the values at these points in time. So this is what we have, and we can stack graph or the normal graph, or how you want to see. You can see more examples are available. So whatever contents, whatever this metrics were available, let me open another version of this targets and node exporter, control F, and this is what I collected from here. So you can use any of them team. That was one instant. But if you want to monitor continuously, then you can use it in your query. So node exporter is pulling that and displaying that in the graph. Prometheus is pulling the data from node exporter endpoint, which node exporter is collecting from my Linux machine. Every given interval, default interval is probably 5 seconds. I need to check that configuration. But after every 5 seconds or 15 seconds, whatever the default interval is going there and pulling that and then plotting the graph there. And you can use any of these metrics, and I'll recommend that you spend at least 15 extra minutes in identifying the metric of your choice. Of course, you can use the filters here to find out the filters of your choice, or network, for example. So you can use any metrics from this matrix available to create a query. For more queries, I will show you. This is another query. For example, this rate CPU seconds total mode is system. So in the system mode, I would like to add one more panel here, and I can write the query here, and I can execute the query. So this is another data. I can plot a graph also, and I can change it to 5 minute 5M, and that will show me the last 5 minutes of data. So I can write these queries, and in Prometheus query language PromQL, this PromQL, these queries are coming from Prometheus query language, like rate, then these mode, and this is the label which I am specifying, and this is in square bracket duration I'm specifying. We need to understand this in Prometheus query language. So once the metrics are available, once you understand Prometheus query language, then it will be easy for you to monitor anything. But let me tell you, don't expect Prometheus doing wonders and good visualization, eye-catching visualization. No. For that purpose, we will be using Grafana to see the same data, same visualization in different beautiful graphs, beautiful panels that you have to watch for. So this is one example of node exporter I configured. Let's proceed with the next example. Next example is for cAdvisor. Next configuration, cAdvisor is the container advisor. Means how can we monitor our application running in containers? Container advisor helps you with that. So to enable container advisor to work with container advisor, because the application I'm going to deploy will be in the form of a complete stack with sample application and multiple containers, and Prometheus also running in the container format. But interestingly, I will be using the same prometheus.yml file in the container also. So in order to work with container temporarily, I have to disable my Prometheus. So I have stopped Prometheus, disable Prometheus, and Prometheus is not running now. And Prometheus is disabled. It will not start till I start it manually and enable it later on. So let's work with the cAdvisor, that is container advisor. So we are going to use the same file for container advisor as well. So I'm going to use a target here first. So I'm pasting this cAdvisor target. So that means job name, same format. Remember the format, never ever lose that format. And indentation, be extremely careful about it. And this indentation will be used in the same format the way it is given. So this is cAdvisor. Now I have configured cAdvisor job, but is available at cAdvisor. Host name is cAdvisor, port number 8080. So, and this is where my cAdvisor will be running. So it will available at cAdvisor hostname port number 8080, and this is my target for my Prometheus. These two will be down because I will be using cAdvisor. So therefore, node exporter may be available, maybe not. But I'm not interested. My interest for right now is the container monitoring. So let's create some containers for this purpose. What is this Docker Compose file team? Multiple containers which are linked with each other. It should be in YML format. So let me explain this file bits by bits, line by line. Docker Compose is used to bring a stack of containers defined in one file and which probably are linked and which have a common networking. So let's understand services. So these containers which are placed inside a Docker Compose, we call them as services. So now you will easily understand that there are three containers that will be created. So first is Prometheus container will be created. Second, cAdvisor container will be created. And third, Redis container will be created. because we are doing it from learning perspective, so we'll not go into the details of each of these Prometheus, but rather our focus will be the cAdvisor. Prometheus will run inside the container. The base image on the container image on which the Prometheus will run is available on Docker Hub at this prom/Prometheus latest image. And port number mapping is 9090 because I already disabled my existing one. And the command will be the configuration file, the same prometheus.yml file I'm going to use. Volumes where the data will be stored, the same YML I'm going to use. Depends on cAdvisor. This is the link I'm creating. So it will be using cAdvisor. cAdvisor is mandatory for this. So cAdvisor is using this image from Google Containers, cAdvisor image, and this is the container name which will be running, and this container name will also be the host name. That is the reason, if you recollect, in prometheus.yml I specify the hostname as cAdvisor :8080, and that's why this advisor hostname and the port number 8080 mapping. This is receiving at this port on my host machine will be forwarded to 8080 in my container, because container are lightweight environment running in isolated environment. So it's a virtualization lightweight environment which give you an isolated environment to your application. And these are volumes, means persistent storage. It depends on Redis, and this is a Redis. So this is the container complete stack which will be created. So I need to go to this directory in order to bring up the entire stack. So I'll go to this directory. You should be in the directory where your Docker Compose is. So this is the Docker Compose. So I can use now Docker -compose and then up in detached mode. So it will automatically search for the file with the name docker-compose.yml, and it will bring up the entire stack specified in Docker Compose. So it will pull all the images which were mentioned. One was Prometheus, second was cAdvisor, third was Redis. So it is pulling all those images, and it will bring all those three containers live. And I will be able to access these containers: Prometheus at port number 9090, cAdvisor at port number 8080. And if you recollect, yesterday I opened port number 8080 also from my firewall. So I don't need that to open port number 8080. Let me do that once again if you don't recollect. In the meanwhile, it is working there. So firewall -cmd permanent add -port equal to, maybe internet is okay, maybe Zoom is creating problem. So wait, typo, okay, sorry, permanent where, firewall, yeah, sorry, so yeah, sorry, firewall cmd permanent add port 8080 TCP. This is already added. Yeah, I got that answer already added. And 9090 also I added. That's also already there. So I don't need that. That's why I was aware of these ports and I opened earlier. So now containers are running. So I can directly go and open my 8080 port number where my cAdvisor will be running. And this is my cAdvisor. Now, if you try that second lab on Podman, you will not see these containers, Docker containers. So these are the containers: cAdvisor, Prometheus, Redis. If you try the Podman lab, these containers will be only this part. cAdvisor will be not be mentioned. You will see that inner part, what is given in parentheses: system, slice, Docker. Even the Docker will be not there. Will be some ID, not the Docker. So therefore, this helps you in understanding this cAdvisor better, because this is implemented using Docker, not Podman as of now. So we'll be following Docker. That's why I've given you two labs. Don't try the second lab right now. Later on, if if you import the second machine and try separately, independently, you are free to do that. Now let's see how Container Advisor is monitoring the containers. Let's go one by one. This is overall. Overall means the node. So this is limit 4 GB. This is because this is my RAM on my node. Swap 2.7 GB because this is what I configured. And this overview, CPU utilization. This is gauge. We call them as gauge. Gauge which can go up and down. and so therefore CPU usage you can see is going up and down. So CPU total uses per core. I have 2 cores, total 3 cores I created. I remember my machine is 3 core. I'll show you. This machine is having 3 cores: system, processor, and you see there are 3 processors. So I given this machine 3 processors. That's why you are seeing 3 processors. Uses breakdown, total memory uses, and this is interfaces, network. This is node. Remember, I'm talking about the node. Node means my machine itself. So these are interfaces which I have on my machine. So this interface have these details. So and file system storage and total CPU usage. This is overall. Now if I go to a one cAdvisor or Redis, let's say Redis. This is a Redis container. So I'm monitoring. This is Redis, about Redis. Reservation, no memory limitation, unlimited, no limit I specified, swap space unlimited. So allowed core 0, 1 and 2, shared 1 GPU, and this is my specific container I'm monitoring right now. So this is for one container. Similarly, I can check that Prometheus container. This is my Prometheus container monitoring. So monitoring the containers and the node, that's what the cAdvisor is for. So cAdvisor is to monitor the containers. And remember, it makes the data available for Prometheus also, because Prometheus is also running at the same. So I can write few queries in my this Prometheus container memory uses in bytes for Redis. Show me that. And graph, plot me a graph. Come on, show me. So this is for last 5 minutes I should use 5M. And you see this is my memory usage for my this container, Redis container, and this is the memory selector. If I want to use it for cAdvisor, I can use cAdvisor, cAdvisor, yes. So this will show me the memory usage for cAdvisor. Similarly, I can check for Prometheus also. What all metrics it is available, you know it very well. Go to the targets, check that cAdvisor target, and check the metrics which are exposed by this. Oh, come on, localhost metrics, Prometheus, show more, this one. Externally means you will not be able to access that here. So it is available inside the cAdvisor container. In order to make it visible here, we need to do some port forwarding. That is possible if you do that. So cAdvisor is able to monitor, able to pull the data from containers, and we are able to monitor that. These two topics are, one is for monitoring the node, the machine itself. Second was monitoring the containers, and I demonstrated. My next session is on these two topics plus some advanced topic. So agenda of this session is what you have seen during the demonstration: monitoring Linux host metrics with node exporter, monitoring Docker container metrics using cAdvisor, making Prometheus highly available, scaling Prometheus deployments. These are the main topics. Node exporter is one example I quoted for Linux machine. In general, we can say that for well-known applications, servers and databases, Prometheus or community have built-in exporters that you can use to monitor your targets. Exporters are basically any script. That's precisely I was trying to explain in the morning. They are binary program, C language program or shell script or anything. So any script or any service that fetch specific metrics of your interest, so you develop your own. Or there are 2 ways to look at it. You develop your own, and second, there's no point reinventing the wheel. Community has already developed beautiful exporters, so why would you do that? But maybe you have specific needs, so you can develop your own. So point is, based on our use case and our requirement, we may use existing exporters developed by community, or we can develop our own. So which can fetch specific metrics from your system and then give data in Prometheus format. Remember format, the Prometheus store data in what format? This is the main way of monitoring target with Prometheus. Node exporter is a Prometheus exporter that exposes hardware and kernel related metrics from your Linux machine. Therefore, you can use Node exporter to monitor file systems, disk, CPU, network statistics of your computer system. That's precisely what Node exporter is. So how do you install? It is a simple binary, as we have seen. Download the binary, extract it, copy it, and directly run it. But as you know that I'm talking about both the options. One is creating a proper systemd script and then launching it using as a system script, and then stopping, starting, managing, or directly open a terminal and run the binary. It is as simple as that. So that depends on your deployment, how you want to deploy it. I am considering two examples always. One is during presentation where I talk about you can directly download and extract and launch it. Or second, in the lab assignment where we are doing a proper deployment, the way we go for any Linux service. Once the node exporter, sorry, is installed and running, you can verify the metrics are being exported by using curl metric endpoint. So curl localhost 9100 metrics. So you can use curl command to directly pull the metrics and display the metrics on the command line. You should see the output like this. In fact, we have seen the same matrix on the Prometheus page when I selected exporter and matrix URL. Configuring Prometheus instances. Prometheus instance needs to be properly configured in order to access node exporter matrix. This prometheus.yml file, I explained during my demonstration that you need to configure it as a job. This was the job name. Give any job name. Static configuration, you need to specify the host name and the port number, and this is how you specify the target. So you need to specify the target with a proper configuration, how you are configuring it. So the name, static configuration, and the target, that's how you specify your scrap. So I configured in the similar way, and this is a global setting. 15 seconds is the default. After every 15 seconds it's going to go and collect that metric. You can configure it 5 seconds, 1 second, 3 seconds, whatever you comfortable to you, whatever your requirement is, default scrap interval. After that, the Prometheus is scrapping the metric. You can explore these metrics using Prometheus UI, also known as expression browser. We have seen that. Navigate to localhost 9090 graph and use metric main expression bar at the top of the page to enter the expression, which you have seen in my case. These are some of the Prometheus query language. You will understand in more detail in the next lecture. As an example, this rate, node CPU seconds total, node name is system, and 1 minute. Meaning here is the average amount of CPU time spent in system mode per second, and this 1 minute means aggregate over last 1 minute in seconds. Similarly, node file system available bytes, the file system space available in known root users to known root users. Node rate node network receive bytes total in last 1 minute. So the average network traffic received per second over last 1 minute. So that's how we use the metric. These are some of the examples. All the metrics are available, and above every metric there's a hash, that means comment and explanation of that metric, what this metric will be. Implementing node exporter step by step. Step 1, create alerting rules in Prometheus. Say rules.yml. In the rules.yml, specify the condition when you would like to be alerted. So this is rule example. Group is all instances. Rules, alert is instance down. Condition for alerting, you are specifying like expression up equal to 0 and for 1 minute. So if the instance is down for 1 minute, because we are saying up equal to 0 for 1 minute. So if the instance is down for 1 minute, this is the condition. Annotation, additional information label to store more information about this, about your down. So title, that is instance name is down. Description, this instance of job this has been down for more than 1 minute. So this is annotation we create in the rule for alert manager. Labels, additional labels to be attached to the alert can be also be specified, like label severity is critical. Obviously, if the instance is down for more than 1 minute, we call it as critical. So if the severity is critical, we can specify where the alerts of severity level critical should land up. So this severity will help us in configuring where the destination should be, where the alert should go. This is severity. So this is a very good example of creating rules based on our node exporter configuration, which will send the alerts based on our station settings. So which means if any of the instances are going to be down, which is specified by up equal to 0 for 1 minute, then alert will be fired. Annotations and labels in the example are used to store additional information about alerts. For those, you can use templated variables also, like this is a templated variable. You use this double curly braces and variable name dot instance name. So this is a templated variable which are then interpolated into specific instances, like for example localhost colon 9100. So link rules with Prometheus, that will be step 1. Once your rule.yml file is ready, you need to link the file to prometheus.yml file. So this prometheus.yml will look like this: scrap interval, evolution interval, rules file is rule.yml. And this rules will be taken from rules file, and this is alerting now. Alert manager is configured because our alert manager is running. So static targets is alert manager default port is 9093. And then scrap configuration, this is your normal scrap configuration data. So we are specifying this based on this rule, alert will be fired. Download and extract alert manager from this, install it, we have already done that. To see the annotation that you added in the step above, click on plus info and you will see those alerts. Monitoring Docker container metrics using cAdvisor. cAdvisor will monitor all your containers. Container advisor, so container running, Docker containers are running. cAdvisor Docker stats will node exporters will make the data available to Prometheus. Well, Prometheus will go and scrap these targets based on the cAdvisor. So cAdvisor make the data available for Prometheus to scrap, to monitor. In fact, our cycle is incomplete. cAdvisor is not very beautiful monitoring. Best thing is when we sorry, we send the data to Prometheus in time series data format, and then we use this data to visualize in the Grafana, which we will do on day 4. That will the cycle that will complete our cycle of monitoring. So cAdvisor sending exposing the data for Prometheus. Prometheus is scrapping it, and Grafana is using Prometheus as a data source, and then we are creating these beautiful graphs panels to visualize our monitoring system, to monitor our system. So the cAdvisor or the container advisor provides an understanding of the resource uses and performance characteristics of running containers. It is a daemon that collects, aggregates, processes, and exports information about running instances. Specifically for each container, it keeps resource isolation parameters, historical resource uses, histograms of complete historical uses, resource uses, and network statistics. A lot of data can be captured by cAdvisor. The data is exposed by container level and machine level. You have seen that. The first landing page was making the data of the entire machine. Then inside the container, we could monitor the container specific data. It has a native support for Docker containers. Next is high availability. Initial high availability Prometheus. For most people, Already operating in Kubernetes world, the typical way of getting Prometheus to be highly available is simply use Kubernetes itself. That is, to have multiple instances of Prometheus and to deploy it into Kubernetes so that Kubernetes can manage the temporary loss of the infrastructure. But we have a problem. Problem here is this approach have some problems unsolved. For example, data retention. Prometheus will only keep a small window of data. If you want to review historical data to see what system was doing last week or last month, you can't do that. Second is data inconsistency. Just putting a load balancer in front of multiple Prometheus assume that all of them were up and able to scrape the same metrics, which may not be true. A new instance starting up will have no historical data, so will not have consistency in the data. And third is hidden outages. If Prometheus is supposed to be monitoring Kubernetes, then there is a potential problem of an outage of Kubernetes not being reported because Prometheus itself was not up to notice it. The third problem can be solved using auto-scaling type of functionality. So here we need a permanent solution for this historical data, for this open the wide window and store the data persistently for long-term storage, LTS. So Thanos address many of the problems and it is open source. We are not going deployment and working, but yes, we understand what Thanos is. That will give you understanding of what is the way ahead for me if I want to store the data for long term. That is, what can I do for my persistent storage of the data. So this is where I can talk about one example, one application which is available, and then you'll find out more and you can do a comparative study. So Thanos involves adding a set of components to your existing Prometheus deployment, which establishes an unified monitoring system across all clusters and additionally provide unbounded historical data storage, long-term storage. Thanos allows the blocks Thanos allows for the blocks Prometheus stores to be uploaded. That's what the purpose of Thanos is. So if I have to define Thanos, I'll use the word adapter. I can use this, though you may not find this word in documentation, but if it is, that will not be wrong for my understanding. So Thanos allows for the blocks of Prometheus to be uploaded to long-term storage such as AWS S3 and also for these blocks to be queried. So it is a midway, this is the middleman between long-term storage and Prometheus. This is where Thanos sits into. So to expose the data in the format which Prometheus understand and store the data which S3 bucket is used. So for long-term queries, Thanos can sit between the data and Prometheus and thereby configuring a long-term storage behind it. Thanos has the advantage that it exposes a Prometheus compatible API. So it can be directly used by other tools such as Grafana. That's a benefit of Thanos. Thanos is able to query the blocks from multiple Prometheus setups and deduplicate them into single response stream. This is a very good example of Thanos deployment. To run Prometheus high available alongside the Thanos require auto scaling group. Auto scaling where we specify automatically scaled. So the user sitting here and accessing through the node network load balancer. So you query the auto scaling group where the auto scaling is group and you are sending the Thanos query to it. So again, the Thanos store is behind the network load balancer. This is another one Thanos store, and the Thanos store will pull the data from the bucket. There's one option is that you directly write the query, Thanos query, and directly you send the query to Prometheus, Alertmanager, and Thanos store. So this is another auto scaling group. So this bucket is used to store the data, and this is the auto scaling group. Compact Thanos compactor means storing the data in compact format, will compact those all data and put them into the bucket. So Thanos can sit between Prometheus and your long-term persistent storage in order to make the historical data available to you. How can we scale Prometheus deployments? That is a very challenging part, and there are a lot of unanswered questions. I will not be able to give you a straight, simple answer because things are not very clear on this part. A Prometheus with millions of matrix can use more than 100 GB of RAM, and that can be issue running in Kubernetes. The problem is it is not designed. That's why I categorically refuse to answer and address this, because it is not designed to be scaled horizontally. If you want a workaround, what are the possible ways? Let's discuss that also. So once you hit the limit of vertical scaling, you are done. There's a major concern. There are some workarounds for this issue, like shredding different metrics throughout several Prometheus servers, but that's a tricky process. When we are doing vertical scaling, we are converting one cat into tiger. In a real life, horizontal scaling is like this when you are doing node scaling or auto scaling in instances in AWS or Oracle Cloud. Then it's the same node, multiple copies of the same node. This is called horizontal scaling. So same cat converted to multiple cats of the same breed, same type. But when it comes to Prometheus, let me give you this picture that Prometheus horizontal scaling is 10 different breeds or 20 different breeds, but multiple cats of different breeds. That's a way. So that's a very tricky, very complex process. But this is what it is possible because Prometheus does not support it out of box. That's you need to understand that how I can scale Prometheus deployment. Going to be very tricky. It adds complexity to the setup and can make troubleshooting very difficult because the instances are not of same type. Currently, there are several open source projects to provide long-term storage, LTS. These community projects are ahead of REST, Cortex, Thanos, or M3. And this is the long-term storage for Prometheus, Cortex, Thanos, M3, Victoria, and SysDig. So whether you are using Kubernetes or Prometheus, you can use this tool long-term storage to write the data, to take the data from Prometheus or your deployment and store them persistently for long-term storage and make the data available for Grafana also. They are compatible to Grafana. This icon is for Grafana. So they are available for Grafana. They make the data available for Grafana also to query and to visualize. So that's the big picture of monitoring tools team. So complications are architecture is complex, can require a lot of efforts to deploy, optimize, and maintain the monitoring self-run service. Operation cost can be high. You can leverage managed databases like DynamoDB, but you still need to scale the rest of the monitoring services, and the metrics throughout throughput can be very high. These projects are still in the early stages of development and can be tricky to run in production even with a dedicated team. More on this is good for your good article for you from D Zone, Developer Zone article, Prometheus matrix based auto scaling in Kubernetes. How can we do that? This article is worth reading. That's all for this session. Thank you very much.